All right, here's a little bonus video for you for reviewing arrays. So you can see I have drawn here my address, my value, and my array here as my titles for my top. We're going to talk about how to think about arrays in memory, and hopefully this will help you be able to understand strings a little bit better. So if you remember from 106, the analogy I used for computer memory was a filing cabinet. And inside your filing cabinet, you have a bunch of different drawer sizes. We have the little drawers at the top that we can pull out. Those are the 1 byte sizes. These are for storing chars. We have the medium-sized drawers, 32 bits or 4 bytes for storing ints and floats. And we have the really, really big drawers at the bottom, 8 bytes or 64 bits for storing doubles. Now with strings, we're only going to be using those top filing cabinets, right? The drawers, we're only going to be using the small ones. If we're storing characters, we only need 1 byte of memory. So we're going to assume every single one of these is just 1 byte of memory away from each other. So if I go to write my addresses, and I'm not going to write them in hex just for simplicity's sake, I don't have to jump by 4 anymore, and I don't have to jump by 8. I can just count 1 by 1. All right, so for example, if I started my memory at 128, I would then have enough memory chunks, right? Enough filing cabinet drawers, enough bytes to be able to go until 136 here. Which means I can store, 9 characters? So let's say I have an array, and in this case, my array would be of strings, right? It's a string, so it would be of characters. Then I can say, okay, I'm storing 1 individual character per memory chunk, or per drawer, or per byte. Now let's say I store EGR 107. That's the example that we looked at throughout the PowerPoint. I have E stored in my first memory unit, and then G, etc., as I go down. So when I declare a normal array, right, a numerical array like we've seen before, I would just declare it from the very start of this to the very end. And I would have something like this. Maybe I have an array called my array, right? My array, and it's 6 big. If you remember though, the element numbers don't go up to 6. They'd be element 0, 1, 2, 3, 4, and 5. Okay, that's for a numerical array, remember. What do we have to do special now for a string array when we want to store characters? That's right, we have to add 1 more because our processor has to know where that string ends. If it doesn't know where the string ends, it will continue printing everything that comes after this in memory until it randomly finds a null character. And that's probably going to be a very long time and a lot of characters and a lot of wasted processing. So let's look at what it would look like to declare a string, that special type of character array. Okay, you'll notice I underlined this a bunch of times in purple. What did we change? Well, first, I changed the name, right? I call it my string instead of my array. They're still both arrays. And now I've added 7. I have to add this extra memory slot. And depending on how I initialized my array and assigned it, I may have to add that null character manually if I do them one at a time, or if I'm using scanf or an initial declaration, static initialization it's called, it will add it for me and I don't have to worry about it. But no matter what, I have to have that null character, that \0, and the last spot of my character array or of my string. Now, one last piece to mention here. If you remember, declaring an array, when you declare an array, you're automatically declaring a pointer. Now, what part of that array is the actual pointer? The name. If I talk about any element inside this array, string or array, it doesn't matter. If I say my string 1, that would mean this element right here, and I could go there and I could see that it's a G. But what if I just say the name of it? What if I just say my string? What is my string? My string is the address of the start of the array. This is the case for any array, whether it's a string or it's numerical. The name of the array is the address of the start of the array. So when you think about printing and using scanf and printf and fgetUs and fputUs and putUs and getUs and all the string functions, you have to remember you're using an actual pointer. So if you get errors in your code, they're going to give you pointer errors and likely data type pointer errors. So make sure you understand that you're actually using a pointer when you use the name. So for example, my string, in this case, just the name of my array here, is actually equal to this. That's an ampersand. I have bad ampersands. Ampersand my string 0, or the address of the 0th element of the array, which means this address, 128. So I just wanted to do a quick review on arrays for you and kind of apply them to strings, just in case you didn't remember everything we talked about in 106. If this is starting to come back to you, you'll probably be okay. If you think you need a little bit more practice, you can actually go ahead and head back to the array section in Zybooks and take a little bit more detailed look, work through some of the problems they have there for you, and it should jog your memory. Thanks for tuning in to this bonus video on arrays and strings and how they work in computer memory.